In this video, I'll give you an overview about AWS Security. To begin with, AWS is built to satisfy the requirements of most security-sensitive customers. It operates under a shared responsibility model, meaning that AWS is responsible for the security of the underlying cloud infrastructure. Meanwhile, customers have the choice to do their own security configurations in the cloud. So, in other words, AWS is responsible for the security of the cloud, and the customers are responsible for their security in the cloud. As you can see here in the diagram, the levels of responsibilities between AWS and the customers are split above the infrastructure layer: networking, database, storage, and compute. This is a generic diagram. The level of responsibilities will differ based on the service provided. AWS environment is continuously audited and compliant with many standards. It has many assurance programs, as you can see. It can provide you with templates and control mapping that will help you establish compliance for your own environment in the cloud. The marketplace in AWS is a one-stop shop for familiar tool that you've been using on-prem. Now you can use the same tools on the cloud. Advanced threat analytics, SIEM solutions, network security, vulnerability assessment, IDS, IPS, PAM solutions, CASB solutions, identity, access management solutions, endpoint management, etc. If you want to define security on the cloud, we can abbreviate it in 4 words. It's visibility, auditability, controllability, and agility. We'll now discuss the layered approach security for AWS. So AWS offers various tools across all the domains: security tools at the networking layer, configuration management, access control, data security, and of course monitoring and logging. Discussing network security, the most important thing to highlight is the built-in firewalls that you can control, who has access to your instances. The firewalls will allow you to create private networks within AWS and control access to all the subnets you own. Encryption is by default turned on between these instances. You as well have the options to connect remotely to your AWS environment from your on-prem environment. And on top of that, AWS provides DDoS mitigation technologies as part of auto-scaling. From the configuration management perspective, AWS provides various tools that ensure that cloud resources comply with organizational standards and best practices. You can track, manage changes to your resources over the time. You as well have access to management tools to create standard, pre-configured, and hardened virtual machine instances, aka EC2 instances in the language of AWS. So you will be able to apply your organizational standards for deploying resources on the cloud. From the access control perspective, you can control, define, manage user access policies across all the services available. You'll as well define access keys for programmatic access by using keys that you can fully control. As well, you can generate keys for SSH login to your virtual machines. MFA is an option there to enable. It's always recommended to enable it. You can as well integrate the cloud environment with your corporate directory, such as Active Directory, and you will be able to fine-grain access using the IAM module, which is the Identity and Access Management module, to give appropriate permissions to all the users. From the data security perspective, data at rest encryption for AWS storage and database services is there. When you say data at rest, it is either in databases, relational databases, non-relational databases, and the S3, which is the simple storage services offered by Amazon. You can manage the keys, or AWS will do that on your behalf. Talking about the multiple layers of security, especially in the virtual machine environment, or the EC2, we can see that each of the items build on the capabilities of each other. From the layered security approach, you have the host operating system. On top of that, you have the guest operating system. On top of that, you have the firewall. On top of that, you have control over the API calls, and so on and so forth. In this approach, each customer has their own data, has their own environment, which is totally separate from the data of other customers. So different instances running on the same physical machine are isolated, as we said. AWS firewall resides within the hypervisor layer between the physical network and the instant virtual interfaces. Instant neighbors have no more access to that instance than any other host on the internet. Virtualized disks are used proprietary to AWS, and EFS, encrypted file systems, can be run on top of the virtual disk device. From the AWS perspective, only their administrators with business need to access management panels are required to do that, and as per their claim, they use multi-factor authentication, and all of their access is audited and logged. From the guest perspective, it is under your full control. You have root access to that, and AWS does not have any rights or access to your resources or instances, again, as per their claim. So here is the full list of security applications that are available on AWS. So we'll do a high-level overview to each of those. Let's start by the directory services. It enables SSO for Amazon EC2 instances and applications compatible with Active Directory. So you can actually use Microsoft Active Directory in AWS Cloud. Credentials are managed by AWS, but you have access to the IAM module, which is the Identity and Access Management module. You'll be able to create users, groups, assign roles, and it can be federated with your own systems. The Trusted Advisor is a very nice tool that you can use to check your current spendings, the performance of your cloud, and the posture of your security. You have two main packages. The basic is free, and the paid has advanced analytics that you can unlock. CloudTrail gives you deep visibility into your API calls, so you'll be able to see who did what, from where, and when. CloudTrail offers alert notification when specific events occur or certain thresholds are exceeded. KMS, or Key Management Services, is a managed service that makes it easy for you to create and control your own encryption keys. It supports encrypting data at rest and data at transit. It's integrated with AWS SDKs and AWS services, and with CloudTrail, so that it provides auditable logs to help you with your regulatory and compliance activities. CloudWatch gives you visibility into your resource utilization and operational performance with lots of beneficial metrics. You can set alarms, thresholds, or trigger auto-scaling. It is useful for log aggregation, monitoring, and troubleshooting. AWS Config is a fully managed service that provides you with an inventory of your AWS resources. It lets you audit the resource configuration history, notifies you of resource configuration changes. The service catalog allows you to create and manage catalog of IT services, that are approved by your corporate policy to be used on AWS. You can publish virtual machines that can be deployed while maintaining the corporate compliance and standards. Cloud HSM is an additional protection layer due to contractual and regulatory compliance. So if you are that advanced, you can go and use Cloud HSM. It's a hardware device that provides you with secure key generation and storage. It's mostly used in critical environments such as the government ones. You'll be able to fully control your encryption keys and cryptographic operations, and you can run it under or from within your VPC or virtual private cloud. It's a fully managed service by AWS, and they will not have access to the keys that you generate. Certificate Manager is another tool that you can use to provision and manage your certificates, SSL, TLS certificates. And of course, it goes without saying that these will help you protect and secure your websites. You can deploy them on ELB, which is the Elastic Load Balancer, or on CloudFront. Now we'll discuss a very important concept in AWS, which is VPC or Virtual Private Cloud. All the resources within your VPC can communicate with each other unless you explicitly negate that. So the main purpose of VPC is to secure communication with outside and just open communication with inside. So you'll have your private cloud securely running on the internet. VPC security includes security groups, network access control lists, routing tables, and external gateways. Each subnet within the VPC is associated with a routing table. A complete VPC firewall solution for incoming and outgoing traffic is there. If you want to connect more than one VPC, you can use virtual private gateways. Internet gateways enable you to directly connect VPC to S3 instances and to internet. And as we said earlier, it's the backbone of the secure AWS architecture. Security groups or virtual firewalls. Security groups are virtual firewalls that will help you control the traffic at the instance level. When we say instance, we mean that at virtual machine level, database level, each of the deployed resources. They are considered to be the first line of defense for EC2 instances. Security groups are stateful. It means that responses are always allowed regardless of the outbound rule. When you create a new security group, inbound traffic is denied by default. NACL is a virtual firewall to control incoming and outgoing traffic from a VPC. So security group is a virtual firewall at the resource level, while network access control lists are virtual firewalls at the VPC level. Each subnet is attached to one and only one network access control list, but one access control list can be attached to more than one subnet. VPC flow logs is a security tool that helps you monitor the security of the network and the flow of IP traffic. You can enable that, of course, in addition to CloudTrail. So how we can connect VPCs? You can connect VPC to your on-prem network using a hardware VPN. You can use direct connect service from AWS. It's through authorized partners within different regions in the world. You can as well use AWS VPN Cloud Hub, and you can use software VPN. You can as well peer to VPCs within the same region. EBS or Elastic Block Storage are storage volumes that behave like CRO or unformatted block devices, and security of EBS is really important on the cloud. You can encrypt the EBS volumes and their snapshots using the available encryption tools on AWS using the AES 256 encryption. ELB or Elastic Load Balancer security is really important because, as you know, ELB automatically distributes incoming traffic to targets behind it. So it can take over the encryption and decryption of the channels from the EC2 instance itself. So you'll be able to terminate your TLS connections on the load balancer. It offers the client a single point of contact and can serve as the first line of defense against attacks on your network. It also supports creation of security groups, and as well you can log all the incoming requests to the backend servers. CloudFront is a distributed content to end users with low latency and high data transfer speed. So it's kind of a content delivery network. From the data security perspective, we need to protect data at rest and in transit on the cloud. AWS only uses symmetric encryption for this purpose. The best practices for VPC, as it's the backbone of the security on AWS, is to plan and design VPCs before implementing them. You should take into consideration flexibility, scalability, availability, and security. Don't use the default VPC built in there. Just delete it and create your own VPC from zero. Always use the least privilege principles, so resources, keep the most resources in private network and let them communicate to the internet only if needed through a load balancer. You should create different VPCs for your development, testing, and production environment. It's very important to tag resources because this will help you later on with the reporting. Tag them from the perspective of the version of the OS, the owners, the department, the team running them, the environment, whether it's development, testing, production, etc. Use standard naming conventions that represent the service being provided by the resource. Implement IDS, IPS, and deploy a WAF solution to protect your applications. From the EC2 perspective, best practices are to use a load balancer, employ WAF, employ AWS shields to protect yourself from DDoS attacks, use snapshots to back up all your data and configurations, enable EC2 termination protection so that it's not terminated by a human error or a human mistake. Use certificates based on the latest SSH version available. Use password protective files. Use RDP certificates to connect remotely to Windows instances. And always, of course, monitor, log, and audit access. Going forward, disable password-only access to guest OS and utilize some form of multi-factor authentication to gain access to the instances. Generate and maintain your own key pairs for access. Disable remote login. Use command line logging, and always stay up to date by patching the operating system and the applications running on it. From the IAM best practices or identity and access management, always use strong passwords, enable MFA, use roles instead of users, and use the trusted advisor periodically to gain an overview of what's going on in your cloud. From the data security perspective, the best practices are to use key management services by rotating the keys, classify your data, implement controls based on the classifications of your data, use SSL all the time, use S3 bucket permissions, enable versioning and replication under S3 so that you protect yourself from data loss and data failures. Back up your elastic block storage to S3 bucket. You can always wipe data and decommission instances as per sanitization procedures that can be supported by AWS. Once you're there, once you're on the cloud, always use Amazon Inspector, which is a tool that collects data related to running processes, network, file system configuration data, traffic flow, and secure channels. It's integrated with SNS, which is a service that sends you messages in case where thresholds are exceeded, and it will as well send real-time data to CloudWatch. From the web application firewall perspective, use conditions to stop malicious traffic from suspicious geographical locations, block IPs using your threat intelligence database, and enable the protection against the OWASP top 10 or maybe the OWASP top 25, top 30, whatever. You can always use the WAF of external vendors in case you are not happy with the built-in WAF tool provided by Amazon. AWS Shield will help you protect your network against DDoS attacks It automatically detects and mitigates attack that will result in downtime to your cloud. It's, as you know, very important to avoid auto scaling on the cloud because you'll end up paying more money. So AWS Shield is the right tool for implementation. From the development perspective, all programmatic requests to AWS resources should be signed by your digital signature, like access keys, access key IDs, and API information. AWS Cognito is another user management authentication and synchronization tool that handles authentication and authorization for users across all devices, web and mobile. It can be integrated with social media identity providers. It's compatible with XAML 2.0 standard and can be integrated with CloudTrail and CloudWatch. Last but not least, AWS API Gateway will help you build, manage, publish, maintain, monitor, and secure APIs for any workload running on EC2. It is used mainly by developers to manage and secure APIs, mainly REST APIs.